Hi all, today I am here to present the topic measurement of strain. Now let us have a look at what is strain. Strain is the amount of deformation of a body to an applied force. Strain is defined as the ratio of changing length of the material to the original unaffected length. Strain is a unitless value, but its value is very small. Consider this bar. The bar length is L and diameter is D0. Now applying force in these two directions, which means that the bar is elongated, because of which the length of the bar will increase in very small value delta L and diameter will decrease in very small value delta D. The strain is the ratio of changing length by original length. The most common method for measuring strain is using strain gauge. Strain gauge. Strain gauge was invented in 1938 by Edward E. Simmons and Arthur C. Roach. A strain gauge is a sensor whose resistance varies with applied force. We all know that these force, pressure, tension, weight, etc., they all are related. They can be converted into one form to another form. Therefore, we can use strain gauge to measure force, pressure, tension, etc. Strain gauge is a device whose electrical resistance varies in the proportion of the amount of strain in device. A strain gauge is a strain transducer, that is, a device for measuring dimensional change on the surface of a structural member under test. The most widely used strain gauge is the bonded metallic strain gauge. Working principle. The basic working principle of strain gauge is strain measurement through resistance change. Usually, the strain gauge is made up of copper-nickel alloy foil depending on range of measurement and requirements of applications. This alloy can be changed. If a metal conductor is stretched or compressed, its resistance changing having three reasons, such as its length changes, its diameter changes, and its resistivity changes. How much amount of force is applied to this conductor so that it got stretched, or sometimes we also applied forces so that it got compressed. This phenomenon wherein the resistance of the material change because of the resistivity change is called as piezometric effect. We know that resistance is directly depending on the length and cross-sectional area of the conductor. R is equal to rho L by A, where rho is the resistivity, L is the length, A is the cross-sectional area. Characteristics of strain gauges. They are highly precise and don't get influenced due to temperature. They are ideal for long distance communication as the output is an electrical signal. Strain gauges require easy maintenance and have a long operating life. The production of strain gauge is easy because of the simple operating principle and a small number of components. Strain gauges are suitable for long-term installation. However, they require certain precaution while installing. They are fully encapsulated for protection against handling and installation damage. Here are the references.